So don't worry about following along with this part of the video. I just want you to watch to see what the differences are between animated, active, deforming, static, all that kind of stuff. So we have a point wrinkle right here. I have the name set to Eugene Peace, and right now I have deforming set to 1. Now, as I mentioned, deforming means that any sort of point position changes within SOPs is going to be updated at every single step. So if we go to our DOP sim, on the RBD object, we have it currently set to create active object. And if we have the drop down here, we have a few interesting options. We have create deforming static objects, create deforming active objects. I'm just going to leave it at active for the time being. And if we go forward a few frames, this is what you'll get. So Eugene goes up, and then once the animation is complete, he will fall back down. I should also mention that the animation that I have right here is that. So if we template the wall, it actually goes past the wall like this. That's what the animation is doing right here on the transform. So back to the sim, it's following that animation that we specified, and it's also listening to all the forces, and it's also being affected by all the objects in the scene at the same time. So what we can say is that even though we haven't selected the deforming active object down here, because we've specified the deforming right here, it'll pick up what the transform is doing, and that will override what's happening right here in this menu system. Also, if I say create deforming active objects, and I go back to our wrangle and I get rid of this, this will do the same exact thing. So there you go. It's the same exact result. So that means there's two ways to make something into a deforming object. You can do it here on the dropdown, or you can source in a point attribute which specifies deforming like that. Now, the benefits to doing an attribute as opposed to the dropdown menu is that over time, remember, the geometry is getting updated at every single step. And with the geometry, you can also update this attribute value. So let's say that midway through Eugene going upwards, I wanted to stop listening to the deforming equals 1, and I want to turn deforming off mid-simulation, right? Let's try that. Let's say chi, so channel integer, and we're going to create our own parameter that we can animate called toggle underscore deforming. Okay, so again, we want to start with the value of 1, and then once we're midway through, we turn the animation off, so 0. Also on frame 9, I'm going to keyframe that at 1. So now, in SOPs, this is the animation we have, but once we go to DOPS, we're going to change that over time. So going back to create active objects, let's say that. If we go forward, it's not going to work right away. So far, it's the same exact result. But if we check on this override attributes, you'll notice that we have active, animated, and deforming as potential attributes for this object to look at when it goes to update the geometry at every single step. So in other words, this will pull in the animation that we just specified here with the toggle deforming. And now, if we go forward in the simulation, it will properly update that deforming attribute to 0 midway through the animation. And now, as you can see, deforming stops where you might imagine it would. Okay, so that is deforming with active objects, but what does deforming with static objects look like? Well, we can do that by changing this to a static object. Let's keep deforming on for the time being. We'll just get rid of all that animation and just keep that at 1. And let's see what happens when we decide to use static instead of active. And now with static objects, the animation follows exactly what we've specified in SOPs. Eugene is not being affected by the wall at all. So he's not colliding, he's not being affected by forces like gravity. As a static object, nothing else in the simulation is allowed to modify what is happening with Eugene. However, active objects, such as the brick wall, are affected by static objects. And that's why he's able to break through like this. So hopefully that gives you a good idea of the differences between active and static. Again, if Eugene was active, he would be colliding with the wall, gravity would be affecting him, and it would try to follow the animation, but it wouldn't line up exactly to what we had in SOPs like it is here when we've turned it to a static object instead. Last but not least, we have animated. And so animated, like I said, it's basically just a way of optimizing this whole updated position without rebuilding the collision mesh every single time. So here animated is set to 1. We have the transform. Within DOPS, I have this currently set to an active object though. And so as I go forward, it's not going to work. Because remember, this only works for static objects. So as long as you have active there, this isn't going to work. As you can see, he's just at a standstill. But if I change this to a static object, this will all of a sudden work as you would expect it to. So there we go. Now, one last thing. We've talked about how animated and deforming, they pick up transforms that happen within SOPs. But if you want to grab something that's on the object level, if you want to grab a transform that's on the object level, the way you do that is very easy. You just go ahead and check on this use object transform, and then I'm going to go browse for a SOP. That's this transform test, which basically just has Eugene brought in, and that's it. So given this situation, we'll go forward a few frames, and you'll see that it'll now pick up what's happening on that top object level. So there you have it. That's about it when it comes to active, static, and deforming animated. It seems a little bit complicated at first because there's a lot of terms going on, but if you just try to boil everything down to a couple of simple questions, it's really not too bad when it comes to figuring out what you need in a given situation. The first question to ask yourself is this a active or a static object? And that depends on whether or not this object needs to be affected by other things or needs to be affected by forces. So, I mean, if an object is static, meaning that it's not moving, then make it a static object. But if it's active, if it is moving or it's being affected by something, that's when it's active. So, okay, so that's the first question. And then the second thing you need to ask yourself is whether or not you should use the animated or the deforming. Animated, again, is faster than deforming because it doesn't have to rebuild the collision mesh. But you can only get away with animated when it's a static object and the collision mesh does not need to be updated on every single step. Otherwise, you would use deforming. Okay, so that's about it. And in the next video, let's continue on by having Eugene do a front flip and break through the wall.